in relative peace, gradually using up the hydrogen fuel that makes up their cores. Smaller, cooler stars are incredibly efficient. A red dwarf with 10% the mass of our Sun can burn for 10 trillion years, almost 1,000 times the current age of the universe. By comparison, larger, hotter stars like our Sun burn more quickly. At about 5 billion years old, our own Sun has gone through half its expected lifespan. By observing stars similar to the Sun, scientists now have a good idea of what will happen to our solar system in the distant future. The Sun will grow steadily hotter, causing it to swell into a so-called red giant. When the Sun does this, it will destroy the inner planets of the solar system. Next, the outer layers will puff out, forming a dense cloud of gas and dust that will obscure the visible light from the star. In this stage, it forms a protoplanetary nebula. Only dim infrared emissions from the dust cloud and reflected starlight let astronomers see anything at all. Hubble images of this stage show a wide variety of shapes, hinting at the complex dynamics at work inside. The spiral structure of this nebula is particularly unusual and is likely due to a second orbiting star that is producing swirling patterns in the gas and dust. Over a period of a few thousand years, radiation from this hot remains of the star excites the gas in the nebula, causing it to glow. The once faint nebula now becomes a bright and mysterious cloud called a planetary nebula. This type of nebula populates our galaxy with luminous shapes that draw the gaze of many a skywatcher. Eventually, planetary nebulae fade to nothing as their gas and dust diffuse into space. All that remains is the tiny white dwarf, a form that our Sun will take billions of years from now. Planetary nebulae are more than just beautiful shapes that grace our galactic skies. They show important stages in the life cycle of stars and how they interact with and even shape their surroundings. Hubble has given astronomers the sharpest views yet of these ghostly, dynamic structures. Take the Ring Nebula, just over 2,000 light-years away from Earth. From Earth's perspective, it looks like a simple elliptical body with a fuzzy boundary. But Hubble observations show that the nebula is shaped more like a distorted donut. The donut hole may look empty, but it is full of lower density gas that stretches toward and away from us, creating a shape a little like a rugby ball that's been slotted into the donut's hole. The space surrounding the nebula is turbulent and full of knotty structures that formed long ago. If we were able to rotate the Ring Nebula by 90 degrees and view it side-on, it would look more like the nebula M76, also known as the Little Dumbbell. In the act of dying, Sun-like stars cast most of their mass out into the galactic winds. In time, the atoms in our own Sun may well be swept up into new suns, new solar systems. In the cycles of star birth and star death, The galaxy is dominated by a rare and extremely violent breed. Stars 10 times the mass of our Sun, and even larger, burn hot and fast. Intense temperatures and pressure ignite nuclear fusion reactions in their cores. Hydrogen gas turns to helium, oxygen, carbon, calcium, silicon, all the way to iron. The outward pressure from heat radiating from the star's core is no longer enough to hold it up under the crushing weight of these elements. Gravity wins the battle, and the star's core collapses inward. That produces a shock wave that races out through the star's volume and obliterates it. Of the 200 million odd stars in our galaxy, one goes supernova about every century or so. The last one to be seen in the Milky Way was observed by the astronomer Johannes Kepler in 1604, just 5 years before the invention of the telescope. The most famous supernova in recent years appeared in 1987 in the Large Magellanic Cloud, a dwarf galaxy just above the plane of the Milky Way. It was so bright, it was visible to the naked eye. Launched 3 years later, Hubble has been tracking the evolving spectacle for over a quarter of a century. Astronomers have marveled at the complexity of the explosion, including the patterns etched by its expanding shock wave. Even though a supernova is only bright for a short period of time, the dusty clouds it leaves behind can last for millennia. Their effect on the surrounding interstellar gas lasts even longer. Although no supernova in our galaxy has ever been observed with a telescope, plenty of supernova remnants have been. Hubble's sharp images of their complex structures help explain the sequence of events, as well as the profound impact these explosions have on the galaxy. Take the Crab supernova, one of the most interesting and most studied objects in all of astronomy. Japanese and Chinese astronomers witnessed the explosion in the year 1054. The filaments shown in these images are the tattered remains of the star, consisting mostly of hydrogen. The collapsed core of the star embedded in the center is barely visible in this Hubble image. Yet you can see its effects. The bluish glow comes from electrons whirling at nearly the speed of light around magnetic field lines that extend from the star's collapsed core. Astronomers have been poring over the nebula itself, still growing at a rate of 1,000 kilometers a second. What they've found is that the filaments of matter that roared out of the blast contain large volumes of dust, an array of mostly carbon or silicate compounds that absorb visible light. These solid particles are crucial for the formation of solar systems. Within the Crab Nebula, there is enough dust to make 30 to 40,000 Earths. Galaxies all around the universe bear witness to the dusty legacy of countless supernovae. The bright central region of the famous Pinwheel Galaxy, for example, is surrounded by dark, dusty lanes. In spiral galaxies, hot winds from exploding stars have helped push those clouds toward the periphery, as well as above and below their flat disks. You can see evidence of this in our view of the Milky Way galaxy. Dark dust lanes and ominous clouds dominate our view into the disk, while tendrils of dust reach far above it. Some dust clouds are destined to light up with new stars, as you can see in one of the Milky Way's small companion galaxies, the Large Magellanic Cloud. Its most dramatic feature is the Tarantula Nebula, a bright region of glowing gas and energetic star formation. The tarantula, shown in these Hubble images, glows brightly because hydrogen gas within it is being excited by ultraviolet radiation from newborn stars. In a wider view, the luminous Tarantula Nebula stands out from its host galaxy. It is the brightest known star-forming region in the local universe and one of the most attractive spots in the night sky. Thanks to Hubble, there is a place within our own galaxy where you can see not only stars, but solar systems being born. In the constellation of Orion the Hunter, just under the three stars that make up its belt, is the majestic Orion Nebula. It draws our attention for its beauty and mystery. Ancient civilizations saw meaning as well, including the Maya in what is now southern Mexico and northern Central America. In their story of creation, three of the brightest stars in the Orion constellation represented a hearth. The nebula was the fire that warms it. At 1,500 light-years distance, it's one of the best-known examples of a star-forming nebula. A swirling cloud of gas and dust where stars begin their journey of life. Within it, Hubble astronomers discovered isolated pockets of gas called proplyds. These are protoplanetary disks that form around newborn stars in spinning mixtures of gas and dust. These disks are now thought to be planetary systems in the making. The brightest star in the trapezium star cluster affects the nearby disks by heating up the gas within them, causing them to shine brightly. The excited material produces many glowing cusps that face the bright star. Other interesting features enhance the look of these captivating objects, including jets and dramatic shock waves. They are formed when the stellar wind from the nearby massive star meets gas in the nebula. The interaction produces shapes like boomerangs or arrows. In one case, the shock wave makes the proplyd look like a space jellyfish. The powerful radiation that allows us to see these shapes also threatens their existence. Once heated up, the disks are more likely to dissipate and dissolve, destroying their potential to spawn planets. Some of the bright proplyds are doomed to be torn apart. The dimmer ones are the most likely to survive. Among those that do produce solar systems, Hubble has been documenting